This video is Introduction to Confusion. The matrix, what is it? The confusion matrix is the name for a 2x2 table consisting of 2 rows and 2 columns with which to organize, visualize, and analyze actual observations compared to predictions. The name confusion matrix seems to have been created by the machine learning community. Another name is error matrix. In machine learning and data science, there are a lot of different names for the same or similar concepts and thinking tools. So being aware of different names and being careful with the meaning of words, semantics, is important. We could call it the reality matrix, since the purpose is to enable application of statistics, data science, and machine learning to better understand reality. The terms confusion and error are to describe when and how much a machine learning algorithm is confused, or in other words, generates an error. The confusion matrix, like math and statistics in general, is a way for us to visualize and think about data. As thinking proceeds, it gets more and more complicated. Of note, a great book for lifetime bedtime reading is Road to Reality by Roger Penrose, a Nobel Prize Sherrod awardee. To help us handle complexity, we invent and use new concepts and terms, building on prior concepts and terms going back thousands of years. Before the name confusion matrix was created, the term contingency table was used to describe the same table structure used in statistics, also called crosstabs or two-way tables. A confusion matrix can be thought of as a type of contingency table. Contingency tables are used in many areas, for example, survey science, psychometrics, epidemiology, other health sciences, engineering, business intelligence. The basic table has 2 rows and 2 columns, generating 4 boxes, buckets, or cells. Each set of rows and columns can be thought of as a dimension. The general basic dimensions are actual and predicted. Each dimension can be either the rows or the columns. Each of these 2 dimensions will have the same 2 values. These values are often described as classes or categories. Another word is group. In the basic 2x2 table, the categories can be represented as 0, 1, true and false, positive and negative, present and absent, yes and no, and so forth. Any categories can be studied using this table or matrix. Each dimension and its 2 classes or categories is a variable that has 2 values. Using positive and negative categories, the 4 cells can be labeled true positive, true negative, false positive, and false negative. In supervised machine learning, existing data about actual observations, events, or outcomes, such as occurrence of suicide ideation, thoughts about suicide, formation of a suicide plan, or making a suicide attempt, is used to train or supervise machine learning algorithms. We could then test those algorithms with another set of data to see how well they predict or are confused. In this diagram, the rows are what we predict will happen using data. The data can have multiple categories and many details, and it's how we apply measurement science and machine learning. Result of the prediction can be saying that an individual is going to have a suicide attempt, yes or no. And then we actually observe what happens as yes or no. So in the case that what was predicted is suicide attempt and what actually happened was a suicide attempt, that counts as a true positive. If the prediction said no suicide attempt and no suicide attempt was observed, then that's a true negative. Similarly, false negative and false positives are when the 2 don't match up. How do we make these comparisons? Building on the counts within each cell for true positive, true negative, false positive, and false negative, there are established concepts and arithmetic formulas for these comparisons. These basic concepts are sensitivity, specificity, positive predictive value or precision, negative predictive value, and accuracy. These concepts serve as building blocks for evaluating the prediction performance of machine learning algorithms. We will discuss that further in other videos. These concepts use simple math, but become complicated in how they are used. The more you can practice using these concepts, just like practicing a sport or a music instrument, the more you can automatically apply them to do things. Exercise makes us stronger. It is like pumping iron for our brains. As one exercise so that you can do more to build on these concepts to understand and apply machine learning to answer questions and solve problems, such as how to improve public health. Each of you please create a multiple choice question, MCQ, for this video using the instructional template. Thank you.